All right, so in our new unit, which is Unit 12, we're going to be doing probability and statistics. And we're really going to be starting with statistics, specifically with central tendency, measures of central tendency, how we can plot data using a box and whisker plot, and the measures of central tendency. And so in assignment number 1, we're going to learn how to make a box and whisker plot and interpret it. What the interquartile range is, which you can find from a box and whisker plot. We're going to be introduced to the idea of outliers and how they affect data and make the data skewed one way or the other. And then the measures of central tendency, which is something you've been doing for a while. So let's just go ahead and get started. One thing that if we do this lesson in class, I'll probably have everybody hold their breath and we'll just gather some data about how long everybody can hold their breath. So you have, here we have 25 people, and I don't really know if this is accurate or not. I just kind of made up these seconds so that we would have some data to work with here. But if we're going to make a box and whisker plot, we want to put all of the data in order. And a really good way to put the data in order would be to do something like this. I'm going to make this be 20, and here we're going to have 30, and numbers in the 40s, and numbers in the 50s. And so if I look at the first row here, we've got a 22, we've got a 35, we've got a 42, we've got a 57, and we've got a 26. And that's the first row. Then we have a 40, a 37, a 43, a 42, so I'm going to put that on top because I already have one 42, and a 48, and that's the second row. Then we have a 41, a 25, a 46, a 52, and a 48. If I move on to the fourth row, we've got a 31, a 41, a 40, a 48, and an 18. And then the final row is a 21, a 42, a 37, a 38, and a 30. And so by putting all those numbers in order, now it's really easy to do a lot more with it because the numbers are in order as opposed to just randomly up there. So let me just make this a little bit neater here. We have all the numbers listed in order. And then we're going to take a look at the measures of central tendency. The mean, you know, is just the average. So we've done this before with the arithmetic mean where we had just two numbers. We added them together and divided by 2. Here we would add them together and divide by 25 to find the mean. The median is the numbers that are in the middle. So if we pick the number that is in the middle, in this case, because there are 25 people in our data set, there would be 12 numbers below it and 12 numbers above it, and that would be the number in the very middle would be the median. The mode is the number that occurs the most often, and the range really isn't a measure of central tendency. It's a measure of deviation, how far away things differ from the middle. And so I'm going to have you pause the video right now and just see if you can find those 4 measures based on this data. And then you can restart the video. Hopefully you're able to do that, and you got 38 is the mean. If you add them all together and divide by 25, you get 38. The median is 40, and so we have 12 numbers above 40 and 12 numbers below 40. The mode, you could argue that this doesn't have a mode because it's tied for 42 and 48. If there were like a 3-way tie or a 4-way tie, I probably would say it does not have a mode. But because there's only 2 of them, I would say 42 and 48 are tied for the mode. And then the range, if we go from the distance from 18 all the way to the 57, that's a range of 39 numbers, which is a pretty wide range of numbers. So the next thing we'd want to do is to make a box and whisker plot of this information. And so what I'm going to do here, you've seen me do this before with your tests, how well we've done on our tests. But if I go 20, 30, 40, and 50, first thing I would do is find the median number. And we learned from our last slide that the median is right at 40. So we have half the numbers below 40 and half the numbers above 40. So that means we have 12 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers that are below 40, and then we have the 12 numbers that are above 40 here. And so then what I'm going to do is take the bottom half of the numbers and cut those in half, which means I'd have 6 on above and 6 below. If I take the 6 that are on the bottom, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, we are right between 30 and 31, which is going to be 30.5. That's called the first quartile. So that means a fourth of the people can hold their breath shorter than 30.5 seconds, and 3/4 more than 30.5 seconds. If I do the same thing with the top half, 1, 2, 3, 4, 5, 6 are going to be below it, and then 1, 2, 3, 4, 5, 6 are going to be above it. What's right between 43 and 46? I'm going to average those together. 43 and 46, the average would be 44.5. So that means, there's the decimal point. So that means that half or 3/4 of the people can hold their breath less than 44.5 seconds, and 1/4 could hold it more than 44.5 seconds. What's in this box is called the interquartile range. It goes from 30.5 to 44.5. And what that means is that half of the people can hold their breath between 30.5 seconds and 44.5 seconds. And that distance, which is 14, that's the interquartile range. That's a distance of 14 units, 14 seconds in this case, is the interquartile range. Then we have the whiskers. The top whisker goes to the maximum value, which is 57, and the bottom whisker goes to the minimum value, which is 18. And that is a box and whisker plot. What the box and whisker plot, just the different parts of it, we have the minimum value and the maximum value. As we talked about before, we have the lower quartile, or Q1 is what it's called sometimes, and the upper quartile, which is Q3. Between those two distances is the interquartile range. Right in the middle of all of the data is the median. Sometimes it's called the Q2, or the second quartile. And the distance between the lowest and the highest is the range of the data itself. So if we, let's say we graduate from college and we have 2 companies that have offered us a position. So we've graduated in engineering. And so we take a look at company A, and these box and whisker plots just represent their salaries. Now there's no numbers with these box and whisker plots, but knowing just this information from the box and whisker plot might be enough to help us determine what company we want to go with. Things that you might observe from the first company is that this company, the salaries might start off lower. So you might have an initial offer from this company that's lower than company B, but it also looks like it might be more difficult to move up the pay scale because the median salary is much smaller than in company B, but there's a lot more opportunity for you to make a lot of money way out here than opposed to company B. Now, company B might be more attractive because you might have been offered a beginning level position with a higher salary. The median salary might be higher than company A, but there's not that much room for you to advance and make a lot of money if that's something that you desire when you start working. And so we might say that the box and whisker plot in company A is skewed to the left because most of the data is here. There's a lot of entry-level positions, but not a lot of room to advance. And so the company B is not skewed because it's more balanced from the right to the left. The median number, again, we talked about the median, is the middle number. The interquartile range, now the interquartile range here is bigger than it is here in company B, and that just might mean that there's a wider range of salaries than there is in company B. Most of the employees in company B might be treated the same, where in company A, you advance more, you have more opportunities to make money, but less people get to that spot. And then outliers. Outliers are simply, there might be one person up here who's maybe the president of the company. Second might be way down here. We don't know. but that person could be an outlier, and we're going to talk more about outliers in our next lesson. But that's what we're going to be doing in assignment number 1, and we will go over questions that you have tomorrow in class. We will see you then.